Alright, hit the button. Draft science video number 9. I don't know what that was. Anyway, yeah, we're going to try magnetism. So, I didn't until just now, sort of get this thing to make sense entirely on the magnetism part. You know, to find a way to describe it. So I don't really have a great analogy or image for it. So we're just going to see what happens in describing it, and I'll describe the comparison between gravity and magnetism in just a, you know, so slight bit of background. Both magnetism and gravity work by the same formula, this inverse square rule of, you know, the further you get, the weaker it gets kind of thing, by a factor of 4. I believe it's 4. But anyway, so anyway, let's begin with gravity. So let's first understand what we've decided what gravity is here. So here's two bodies, and the argument being made is that there's pressure from radiation from the universe that equally surrounds all these bodies. It's a pressure created, and that what happens is that pressure is blocked from view from certain perspectives. So the pressure on this item is altered by the shadow of this item. So when the two are in contact with each other, this item can't see pressure from this range of its focus, and so no pressure happens in here. So this becomes a low or no pressure. Let's just call it no pressure zone. And so there's no radioactive pressure in this zone from this one's perspective. And likewise, this one has a narrow view from its center of gravity, blocked by this little item, and so it too has a no pressure zone, in the sense that part of its pressure has been reduced. And you know, that's the attraction is equal on both sides, and it's not really an attraction. What we're talking about is the elimination of pressure. So it's really just that the external pressure forces the two bodies together. A problem with this theory would be that this radiation would, over time, increase the mass of the body. You would assume that stuff goes in. If it's not going out, then how is it affecting the body's motion? And the argument I would now make is that these rays, when they go in, are converted. So let's call them X-rays when they go in. They're not X-rays literally, but let's just call them X-rays. And they're converted to Y-rays out. Okay, so let's just say that the X-rays they are affected by matter. Matter affects them and converts them into Y-rays. And the conversion process imparts a kind of pressure or energy. It's a transferring of energy. So there's no energy in, really. It's what goes in comes out. It's just converted through the process of the transition, and the conversion is the energy that is absorbed by the material body. So essentially the material body. It's another one of these arguments about time, and about how this is all about time. It's about the light on a straight line is timeless, let's say, moving on a straight line. And as soon as it gets some swirls in it, as soon as it does something deviant, as soon as it takes up some time, that creates what we might call mass, or the expression of its energy. Anyway, but its energy is always conserved. So again, the X's go in, the Y's come out. The Y's are completely transparent to all matter. So even though something came in and something came out, the conversion is what creates the capacity for there to be acceleration in a direction, merely because it's changing the internal dynamics of the material body that is also full of energy. So it's changing the energy and the dynamic of the body being moved, and through its acceleration it now has expended a kind of energy that it gets back in terms of when that energy is, it's kinetic energy versus potential energy. but it can be converted back into potential. Anyway, so that's gravity. And now what's happening with magnetism is, let's remember this XY thing. So there are two kinds of radiation, the X and the Y. And so the X is opaque in regular matter, and the Y is transparent. So it's opaque and it will impart pressure, and Y rays do not impart pressure, so they become quite irrelevant to gravity. Now in magnetism, so let's draw a couple of magnets here, or a magnet anyway, and get an idea of what's going on. So the first thing you got to understand about a magnet is that it's composed of this two thing, this north-south, east-west thing is created, but the north-south, whatever, there's two kinds, there's two sides. It's split, and it's split proportionally. Half the magnet is one thing, half the magnet is another thing, and how exactly that line would be expressed, or how that having of its identity. Lots of room for discussion about that and conversation and whatnot. So I'm just going to use a crude diagram and just split it and then split it. So now we can understand that this would be north and this would be south. So we have a top that would be all north and a bottom that would be all south, a side that's south and north-south. So that's a way of understanding that it's not just a simple one side's north, one side's south thing, because we do have the poles on either side. So it does get easted, wested, and the east and west become north and south, kind of thing. So just for understanding's sake, there's two kinds of tissue here, two kinds of arrangement. They're identifiably different elemental structure. It has to do with the arrangement of the electrons, and the arrangement of the atoms and the electrons in the same arrangement. So they're all spinning in one direction, and this side, let's say they're all going this way, and they're all going that way on the other side, or however we're going to describe it. Alright, but now, so the same rules apply in terms of there's this pressure, evenly, the XY rays. So now we have to understand there's both X and Y rays, because material bodies create these Y rays. But anyway, and we have another, so now we have to understand that this radiation has these two forms, and what's happening in a magnet is the same kind of transition. So let us say that what happens with a magnet is that whatever goes in comes out the other side, but then it's converted again. So let's say the pressure wave goes in, it's an X, it gets absorbed, it expels a Y that's transparent, but because it's a magnet, it's not transparent. So you get me. So now the difference is the north is opaque to the X, and you could say the south. And I don't know if this is, so this is where, like I said, we're getting into I'm not sure if we need to even go there. The point is the conversion happens across the poles, so that now what's being expelled, so now when the X pressure comes in, it is absorbed, but it does now convert, because there's this conversion separation. So the X gets converted into a Y, but the Y at this conversion gets converted back into an X. So now an X is going to leave this other side. So before, where it just passed through and there was no incident, no problems, now an X is, now it's expelling not Y rays but X rays again. So it's expelling the same pressure that it received. And so that becomes relevant to now the arrangement of a second magnet, where now you're going to have the circumstance where they're going to be both doing the same thing. So if they're both expelling X's, we're going to have double the pressure. So you can see if they're facing opposite, if they're configured opposite, which would mean their poles are the same. So these are both the north side here, north and north. They're both going to be expelling, from their pressure, instead of shadowing each other, by blocking radiation, as in the gravity example, they're going to be creating higher pressure here, more X's, and that's going to be doing this forcing them apart thing. At the same time, these rays are getting blocked in the normal configuration, which means, well, it's not normal. Normal in the sense that it's still absorbing pressure in these other directions. It's just that it's going to have this extra pressure created by this. Now it has to deal with the real X rays instead of Y rays. So it's basically going to, it's the same amount, obviously. It's conserving the amount, but it's now in this form that has that isn't transparent. And so that's the key point here. And so then when the magnets are in the opposite configuration, where their poles are opposite, the conversion will be opposite, and so there'll be a total block of a double block almost. So it's like double gravity in one direction and double the opposite in the opposite direction. Something like this. They'd be the same. So then you would have north to south. But you can, based on what's getting converted, the conversion transitions are going to change the pressure. Now they'll be doing the exact opposite thing, which is pushing them apart. Pushing them together. See, I didn't do a good job of, this will take a part 2. Because, it's just, it gets a little bit complicated because it really shouldn't be that complicated, and I really should be able to explain it. It's just that it's this, what goes in one form and comes out in another form and affects something else in one form, but doesn't affect the other one in the other form. So what you're basically saying is, it's like, say the south side was sensitive to X-rays, and the north side is that absorbs and converts Y rays. So the north converts Y rays into X's, and the south converts X's into Y's. And so you have this exact opposite effect, which ends up giving you a complete change in the dynamic of the amount of pressure, exactly opposite when they're together to their to their maximum conversion. So it's the conversion that creates the movements. Remember, the conversion is the amount of stuff convertible, the amount of stuff is capable of being changed. It's like in the Earth gravity example. It's the amount of stuff being converted that's creating the shadow. The shadow is in the direction of what this won't be able to convert, because it won't have it won't be getting exposed to pressure from that side. So it won't have anything to convert, and so having nothing to convert, there'll be no pressure. So it has to do a conversion to realize the pressure. It's transparent if it doesn't do the conversion. There's no pressure. There's no acceleration without the conversion. So obviously when they're converting exactly what this isn't sensitive to. So when this one's creating what this one can't see, and this is creating what this can't see, you can see that this would end up pushing them together. And when it's the opposite, you can see that this one's pushing one that it will convert, and this one's creating one that this one will convert. So there's more converting taking place, which means there'll be this action to push them apart. It's probably enough. It's certainly enough to connect the two ideas. And you can certainly feel it in magnets. It really does feel like pressure. When you push two magnets together, the same pole to pole, you can feel it like it's a pressure. which is always been very interesting. And it just seems very intuitively correct that that's what it is, that it is actually a pressure of a kind of radiation, photonic pressure. I do like that word now. But anyway, I don't know if I need to say anything else. But anyway, these, like, obviously these shapes would have something to do with the fact too that the way magnets tend to flip, you know, when they, because it would be a little bit stronger at one end than it would be at the other end, and so it's going to be pushing directionality. You see, this is going to have a certain directionality, and this is going to have a certain directionality, which is going to tend to force them to try to flip. But that's a whole, you know, getting into the more complex dynamics of magnets and their different configurations and arrangements wouldn't, I don't think, be a useful thing to do. What happens to, like, iron filings, you know, around a magnet, you know, where you get these concentric rings that form, you know, where they line up. Well, that's them lining up with the shadow being cast, you know, the pressure shadow, and them attempting to do the same sort of configuration. But obviously, like I said, you can see that because the gradient is not even, they're going to line up in places that don't seem exactly even with the substance. You know, if it was just divided, they're going to line up with these, you know, with the area of this line, the shape of this line is what's going to dictate. Like I say, it could be any kind of shape, and it could have a lot of nuance to it, but again, it's the shape of this halving that is really creating that, you know, these if you know, continue these into circles kind of a thing. But that's really what's creating what appears to be these lines, is the fact that the amount of conversion area is the amount of mass in one state, you know, the north state or the south state, is what's going to dictate those lines, is how much mass of conversion area there is and how much of a shadow it's casting. And so the shadow is going to be very uneven because the distribution of the mass is, you know, the south mass, as you can see there, is not even. It's not like a planet where it's centered. It's very it's not a round shape in its mass. And again, mass will be the important word. It's not so much about the shape. You could have the magnet in a round shape, and it's still going to the arrangement of the magnetism itself is still going to be stuck in an arrangement that's going to have uneven distribution of its mass. Its mass is going to be distributed almost in the yin-yang. Yeah, that's funny how it turns out that way. The poles, instead of one center of gravity for its magnetic mass, it has two centers of gravity for magnetic mass. Magnetic mass, that might be another concept to, you know, keep an eye on. So I'll write that down. Magnetic mass and photon pressure, photonic pressure. Anyway, so yeah, this is probably enough of a starter. I have to figure out if somebody has some idea of how to illustrate what I've just described here, that would be great. But yeah, I know I probably have to do it. But anyway, that's magnetism. Fits with gravity. Looks like this is all just going to fall right into place. So yeah, once you get the foundation right, yeah, you can build something. Yeah. They got it wrong. Anyway, till next time.